might have.
Well, there's been an interesting report in the press recently that the Natural Resources Defense Council, a national environmental group, has suggested that the protocols that are being used by NOAA and the Department of Marine Resources and others are making assumptions about the quantity of intake of seafood, and they're using, they think, too low assumptions. And they've done a small study looking at, but a statistically significant study of 547 people in fishing communities and finding out that they're eating many more times the levels that the government is testing for. What does that suggest? And do you think it's something that really puts people in peril right now?
Well, certainly the tests have not shown any significant damage that you could have from eating fish, even if you double the amount that the tests say. But the point I want to make is that you take that fish out, you batter it up, and you fry it. You're doing more harm by frying the fish than you would if you would take it over here and broil it. So most of the impacts from eating consumption of seafood is going to be how you handle it. Do you smoke it? Do you fry it? Are you using vegetable oils as opposed to some of the better tasting animal product oils that are out there? So that's where your damage would be. If you sit around and you do a lot of imbibing with adult beverages while you're eating all this seafood, that's a risk. If you're sitting around and you're smoking cigarettes in a restaurant, that's a risk. So in my opinion, there is a much larger risk from driving to the restaurant or the family gathering, enjoying the company, including adult beverages, smoking cigarettes if you're so fond to do that, or even from secondhand smoke. All of those represent an incredibly much larger risk than consumption of seafood. There's something like 1 in 100 chance that people that drive will suffer some sort of damage. 1 in 100. And we're talking about 1 in tens of millions potential damage from eating seafood. We're not even close. We would much more at risk from driving to and from the seafood restaurant than we are at consuming the seafood if we went there every day.
Yeah. Well, that's and interestingly, we want to add to that all the coastal states are finding the same things that Mississippi is finding as well.
And of course, you know, the oil spill is not something that's prominent in the news right now, but, you know, where is the oil right now?
Actually, that is something that we're about to talk about in our third segment. We will be addressing that in terms of research that has been published. And is it time for us to move to that topic
yet?
Yes,
let's move into that right
Excellent. I don't know if y'all have anything to say, but I could certainly move straight into what I was going to say, which is that this is our third program. This is the final program that we're producing for television on this project, and we're really shifting our emphasis now to the website, and we're continuing to add content to the website. The website has a lot to say about seafood safety, but it is also going to have a lot to say about some of the peer-reviewed scientific research that's coming out. And so this last segment that we're going to be talking about is to discuss, there's a handful of papers that have come out, maybe 10, that have come out in the literature that really complete the process of science. The scientists, since the oil spill, have been going out, they've been making observations, collecting data, making hypotheses, testing those hypotheses, analyzing data, and now they're at the stage where they can draw their conclusions. And the final part of that process is to send it to the publisher of a journal, a scientific journal. And we're looking today at about 4 papers that do make that final step in peer review. The editor of the journal will take the paper that describes analysis and send it out to colleagues of the scientists who conduct the research. The papers that we're talking about today address questions like how much oil is there, where is the oil, and what does it look like. And they also address another question that's interesting too, which is how are the microbial communities in the Gulf of Mexico responding, and how does that affect hypoxia? And I'm sorry, that term hypoxia means a reduction in the oxygen content or oxygen concentrations in the water column. So I have several papers, and really the ones that we're talking about were all published in October journal, the October journals of the magazine Science, very well-regarded journal, and it's where you put your first research that comes out. The first one is a paper by Dr. Krohn and Dr. Tolstoy. They're at Lamont Doherty Laboratory at Columbia University in New York. They actually put out an estimate, a new actual research paper on how much oil was released during the 84 days of the spill. And they did this using, it's called optical plume velocimetry. So they did image processing of the videos that we all got to see of the oil coming out of the well. They looked at it before and after the riser was removed. They assumed that about 40% of what was coming out of the pipe is liquid oil, not gas. There's rather a lot of uncertainty in these calculations, and they found 68,000 barrels a day were being released into the Gulf, which totals up over 84 days to 4,400,000 barrels of oil, which exceeds the Exxon Valdez in terms of how much oil was spilled. It also exceeds the initial reports that we were given by an order of magnitude. So that's one paper.
Yeah, could I comment a little bit about
Yes.
that? First of all, I think we need to realize that these 4 papers are by 4 different research groups that got an opportunity to go in and look at what was happening 5,000 feet below the ocean surface, so which is very difficult to even collect samples from that depth. So this was incredibly talented people doing very difficult work. But there were thousands of scientists responding to this spill with the Coast Guard, with NOAA, with EPA, the federal agencies. BP brought in their scientists, and the Gulf states had their scientists. So we owe all of these people a debt of gratitude. There were tens of thousands in Houma, in New Orleans at the command center, and many of them were scientists looking at various aspects of a spill. In addition to the Krohn's paper, there were a panel of government scientists that were convened and looked at 4 different ways that you could tell how much oil was coming out of that. Clearly, the initial estimates of the amount of oil going in, 1,000 barrels, 5,000 barrels, were way off base. Mm-hmm. Right? And the early stages, remember that oil hadn't started coming ashore, and it was unclear just how much was being released. As people started looking more carefully at the well, they realized that it was way, way more than 1,000 barrels. I think the current estimates are somewhere around 58 to 60,000 barrels a day. There have been a number of ways to look and determine how much oil. The Krohn paper looked at, they had video pictures of oil flowing into the Gulf, and they could tell how fast the oil was rising. They knew the volume of the plume, and so they could do some calculations to estimate how much of that oil was getting in the environment. They were a great help, but there were a number of scientists that were looking at this for the U.S. Geological Survey and NOAA. The commissioners, Commissioner McNutt and Jane Lubigico, convened panels to find out how much oil. And I'm feeling pretty comfortable that the estimates that people are coming up with now, that is in the 50 to 60,000 barrel per day, are correct estimates for how much oil. Interesting, the BP scientists are starting to challenge those numbers now. They're saying, well, maybe it wasn't quite that much. So this will all be played out over the next several years in the scientific literature. This was the first one of several papers that are going to be coming out, and some data supported by BP will undoubtedly be coming out also. So, but science will ultimately understand exactly how much oil was produced.
And I think you're bringing up an awful lot of really good points. First of all, it's really kind of cool to think about the number of scientists who were involved. And they didn't see their families for weeks and months.
Absolutely.
And that's cool. And the reason that we have selected these papers is because they're the first ones that have made it through that peer review process. Having said that, That doesn't mean this is the final word.
That's correct.
So,
That's right.
as he says, these papers will be challenged not just by BP, but by other scientists who are making other observations. And so that's a really excellent point that you brought up.
Something I'd like to interject just to
Sure.
sort of give the watchers a visual.
Sure.
I sort of liken it to having several parts of a puzzle, and handing them to three different scientists. And the first scientist looks at his and says, well, it looks to me like this is probably a blue crab. And the next scientist says, well, I think this might be a brown pelican. And the next one says, I think it's a redfish. And then they all get together, and time passes, and they get more parts of that puzzle, and they put it together, and somebody says, oh my gosh, it's the Gulf ecosystem. It all
right.
comes together over time as all of these different pieces come together. And that's what we do for a living, day by day.
Absolutely true. And that's a very nice way of putting it. I would have said it's like looking at different parts of an elephant. But that is much nicer.
Much more appropriate.
Exactly. It
How
works
about
for
the
us.
reflex of a whale?
Yeah.
What do you have another study, David?
I do have a couple of other studies. The second one is actually kind of entertaining because we've been hearing about plumes. And this paper is, none of these papers is by a single author, but the only one I'm going to name is the lead author here. His name is Dr. Camilli. I'm not sure if that's how he pronounces it, but he's at Woods Hole in Massachusetts, at the Oceanographic Institute there. This paper came out in early October, and he took part in cruises. He actually organized the cruises in June, and they used autonomous underwater vehicles as well as water sampling over the side of a ship to look to see if there was oil in the water. And they found plumes at about 50 to 500 meters, and they found plumes, a very continuous plume at 1,100 meters of depth. And that plume was 35 kilometers in length, and it persisted for months. The shallower one was more diffuse. Another interesting point about this is that the hydrocarbons varied in composition, which is completely along the lines of what you were talking about. The most important thing in this paper, besides showing the plume and defining how a plume is defined, is that they were able to show this is not from natural sources. There are many methane seeps in the Gulf of Mexico. This is not from those natural seeps. But they also did not confirm huge reductions in oxygen that would be occurring if there were a lot of microbial activity consuming a lot of the oil. So oil being consumed by bacteria uses up oxygen, and there has been concern that the fisheries in the Gulf of Mexico would be at risk because of this oil spill providing that organic matter source. And they did not find that to be a problem.
Yeah, virtually all of the information that Camilli found was in fairly deep areas, and the plumes were fairly dilute. People hear the word plume, and they think of different things. They think of a plume of smoke or a plume of lava flowing down. Well, the plume that people really saw down in the deep Gulf was more like a plume of smoke, very dilute oil leaving. There was not a black layer of oil in the deep water. Oil is less dense than water, so if it's thick enough for you and I to see, it comes up to the surface. It floats up just like a cube of ice would pop to the surface. So it has to be dispersed into these tiny, tiny little droplets, and those are the plumes that Camilli and the other guys talked about.
And it's very interesting here today to wrap this up on this third segment, and we want to remind everyone that we can also let you know that you can find out more on our companion website at spillscience.com. There you can find in-depth information about topics related to the spill, as well as video discussions from scientists studying the effects of the spill in the Gulf of Mexico. You may also want to join our discussion on our blog section of our site, where you can engage in discussions with scientists studying the impacts of the Deepwater Horizon oil spill. Again, all of this you can find at spillscience.com. Some great discussion here today on that, and that's all for this edition of The Science of the Spill. Until next time, I'm Erin Pickens.
And I'm Dr. Bob Thomas.
This program was made possible by a grant from the National Science Foundation. a co-production by Mississippi Public Broadcasting and the University of Southern Mississippi Gulf Coast Research Laboratory.